Hello everyone! In this video, we're going to be talking about the period of a sinusoidal function from a graph. So just as a quick recap, a sinusoidal function can either be sine or a cosine function. It's a general term. And a period, if you don't remember from a couple weeks ago, is the maximum to the next maximum or minimum to the next minimum. Notice that we weren't given those things, but that's okay because we're given kind of half the information. We can figure out the rest from there. So the distance, so for a regular sine function, which is what this is, the distance from a maximum to a minimum is going to be half the period because these are symmetrical. They're all the same, right? It's not leaning to one side. This is going to be, in other words, this side, right, is exactly the same as this side, distance-wise, right? So if I want to know the distance between this maximum and this maximum, I just need this distance plus this distance. And these two distances in the x direction, right? The distance is in the x direction. So we were talking about amplitude and midline, we were talking about the y direction. With period, we're talking about the x direction. So if I have this distance from the maximum to the minimum, then I have half the distance from the maximum to the maximum. So I need to figure out what this distance is and then multiply it by 2. So the distance from the maximum to the minimum times 2 will give me my period. So period, I'm just going to call it P, is going to be, remember, x direction. So this distance, right? So we need pi minus negative pi, and that's going to give us this distance. So it's going to be 2 times pi minus negative pi. Because remember that pi minus negative pi is the distance from here to here, which is half the distance that I need. So I need 2 times that distance. Pi minus negative pi is pi plus pi, which is 2 pi. So I have 2 times 2 pi, which is 4 pi, and that's going to be my period. You're asked for exact values, so if it has a pi in it, leave it as having a pi in it. You're not going to get a decimal approximation. So that would be 4, and then they have a little pi symbol here. So 4 pi. All right, so in this one, we're given something a little bit different. We're told that this point is on the midline. It says it intersects the midline at this point. So this point is on the midline, and we're given a minimum. So we need to go minimum to midline to maximum to minimum. Minimum to midline to maximum, back to midline to get to the minimum again. That's kind of how the graph goes, right? And one period is going to be minimum to minimum or maximum to maximum. You can think of it that way, but we're not given the maximum. So I'm using minimum to minimum in this one. But notice that's 4 things. Here to here, to here, to here, to here. 4 parts of the graph. And they're all equidistant. They're all the same distance from each other because these graphs are very symmetrical. So I need 4 times the distance, the x distance between these 2 points. 4 times the x distance between these 2 points. Because I have 4 pieces of my graph before I get back to a minimum again. So I could say, all right, I'm going from minimum to midline to maximum. So midline to maximum would be the same distance as minimum to midline. And then maximum back to midline would be that same distance again. And then midline to minimum would be that same distance again. So that's why it's 4. 1, 2, 3, 4. All right, so my period is going to be 4 times 5.2 minus 1.2. So that's 4 times 4. 16. So my period here would be 16. So basically what you're doing is you're using the information that they're giving you and the knowledge that these graphs are very symmetrical. So if you can figure out things that are the same distance, figure out how many you need to multiply it by to get the period. Hopefully that makes sense. Let me know if you have any questions, and I will see you in the next video.